Well, good evening, good afternoon, good whatever it is to you. This is Stereo Police, and I've decided to make a video on the Audio Note Kits DAC because of an ensuing purchase, and I had previously asked for some assistance in helping me decide this because of the busyness of my schedule and all the things I talked about. And I had a little time today. So I thought I would make one of my standard comparison videos. I went through the website, the Audio Note Kits website, and I started to try to sort things out. And as I began to get into it, I said, oh, what the heck, I might as well make a video for anyone else, for posterity, for anyone else in the future interested in these things. Because as far as I'm concerned, I really love the Audio Note Kits, but for a guy like me, for my brain, the website has a lot of wonderful pictures and photos, but it's a little lacking on information, and to me it appears to be a bit disorganized. Maybe it's not disorganized, but the way I like to process information, to me it's a bit chaotic and hard to understand. Um, really what's going on, the differences between the models. You really have to fish around a lot. You really got to do a lot of fishing. And so I thought I'd try to organize the information for you and for those in the future interested in these kits. So that's the backstory. And there's so much information, I don't have time to do it all in one fell swoop. So I thought I would get the process rolling and begin with part one. In part one, I'm going to discuss the overall design of basically all of the Audio Note Kit DACs. And we're going to begin discussing the analog board and move forward through each of the different components. I've tried my best to make this as accurate as possible, but of course I'm human and I'm fallible, and there may be some errors and there are some omissions, and that's where you come in. I'm happy to be corrected. It's never an insult. It's an honor. We're a community. Okay. Alrighty, so let's plow right ahead. Okay, so there are, what do we have? One, two, three, four, five, six. I found 7 distinct models in ascending order of both price and presumably quality, right? And they all have a similar architecture to them, but the quality goes up. They're all high quality, by the way. I'm not questioning the quality, but of course, you pay more, you get more. Depends on what you want, and that's where when you start fishing around the website, you scratch your head and go, what am I getting, and what does this mean, and what does that mean, and what does this really do for me? And it's always a value proposition too. We're all not bottomless pits of cash, so it's a value proposition as well. If we were bottomless pits of cash, we would just say, "Oh, screw it. We're just going to, like looking at the menu, going, oh, what's the best piece of beef you have? Well, it's the most expensive. Give me that one." I don't have that kind of scratch. I don't think most of you guys do either. So it's a value proposition. So let's plow right ahead. And of course, I find these DACs to be very special. I've been on the hunt for a DAC for quite a while, and pretty much finalized my decision to the Audio Note Kit DAC. And there are many things that make this special to me, but I'll distill down to a few things. Number one, it's an R2R multi-bit DAC. I'm not going to go tangential and tell you why I feel that's the best way to convert digital to analog, but I do. So that makes it special right off the bat. Number two, it's a vacuum tube buffered instead of using an integrated circuit chip of any kind like an op amp. I'm not a big fan of op amps. Yeah, I know they're good. I know the people, they have their fans out there, but um, I am a fan of vacuum tubes when it comes to certain things, when it comes to many things. So when you couple an R2R with a vacuum tube buffer output running in Class A, you've already got my attention. Yeah, I mean, I'm already, you had me at hello. Is that a famous movie line? Hmm? And there are other things, and I'm not gonna prolong that. We'll we'll flesh or flush. Which one is it? Flesh out or flesh out? Hmm. I always forget. We'll flesh those out later. Yeah, flesh. We'll flesh those out later. And of course, quality components, reputation, and not necessarily built in China. I know. Don't criticize me. I know that there's some good things, some good DACs that come out of China, but there's still some very questionable quality control, some questionable labor standards, and many other questionable things that are beyond our control. You don't know what you're going to get, and I'm just not a fan of that. I just don't want that. Um, so it's just a personal thing for me. I'm not criticizing your equipment. Not at all. Be happy with what you have. You like it, you like it. It's just not for me. And I love the Chinese people. It's not a criticism of that whatsoever. I just nothing like that at all. It's just not, it's just about quality control, too many unknown factors, labor conditions. I just certain things that are personal to me. That's all it is. Okay, that's all it is. So let's first dive into um, let's dive into the overall topology of basically all of them, all of the audio note kit DACs. See, I'm moving right along here. I'm not going tangential on you. I'm not going to waste your time. Well, I probably will at some point. Okay. So I'm going to hit pause. I'm going to hit pause right here and go get a drink of water so I don't start drying up. And forgive me if there's any clicks and pops. I'm wearing this headset and the microphone keeps slamming into my mouth. And I apologize for that. Um, okay. Um, I'm going to hit pause in a second, but we're going to walk through the basic topology of the system. And then we're going to begin with the analog board today, and we're going to look at the analog board. We're going to compare the differences between all the different models and see what's different about them. What makes them, what am I getting for my buck? And we're going to go through each board. We're going to do this with each different board, and as we go in ascending order in quality and price, and see what's different. And let's do this. All right, so I'm going to hit pause right now, and I know there's an F. I know there's an F number for this, but I don't know what it is. So let me hit pause on the pop-up here. All right. All right. Basic topology of all of the DACs. Well, let's begin with. Let me separate out the power supply from the actual DAC circuitry. So up here we have the DAC circuitry itself, and down here we have the power supply. Both are critical. All right, with two different um, basic categories of circuitry. So let's begin with the inputs. You have your inputs to the DAC, and in this particular case, we have the RCA, the standard RCA 75 ohm input for your SPDIF signal, and I think there's a USB optional, which requires a little separate board to convert that USB over to SPDIF, etc. Um, and we begin with that. So you have your inputs, your signal comes in. And the first place it goes is to the DAC board, which is pre-assembled. It's a kit, but that board is pre-assembled, and thank goodness for that. And once it goes into that DAC board extracts the, I'll get into that later, but that DAC board just basically, extracts the ones and zeros from the SPDIF carrier and then converts the digital signal to analog. And in this case, there's going to be a current output, not a voltage. Current output. It's supposed to be a C. Sometimes we draw it as an I. And then we move through some coupling transformers. And we go through the coupling transformers and we move over to the analog board. And in all cases, and this analog board here is critical. Well, it's all critical really, but and this analog board is normally in a normal DAC, and even with R2R DAC, sometimes you'd see an op amp here. Boo! In very good DACs, you might see a discrete circuitry, being used. Some discrete circuitry, some actual real transistors being used. And sometimes it's Class A circuitry, and I'll give a shout out to that. Cheers. But in this case, we have some Class A vacuum tube circuitry. Yay! Right on. So this analog board will convert that current signal to a voltage. So that's IV, current to voltage. And actually, I should say that's what the transformer does here. Current to voltage. That's what the transformer does. Forgive me. And then what this analog board does, it will be that very tiny signal will be to amplify that voltage and provide an appropriate output impedance. No, well, I'm getting ahead of myself. Will amplify that voltage to a sufficient voltage level to drive these output transformers. And then you go through the output transformers, and these output transformers collectively as a symbiotic relationship between this analog board and these output transformers will provide the appropriate signal level for line level, and as well the appropriate output impedance to drive your next device, whatever it is, whatever your next device is, likely a preamplifier of some kind. All right, so there you have it. A little bit odd, quite a mess I've made here. I apologize. All right, so transformers don't need a power supply. All right, your inputs are just inputs. They don't need a power supply. But your DAC board needs a power supply, and your analog board needs a power supply. So what Audio Note Kits has done, and this is pretty standard anyway, is there's two separate power supply systems. So you come in with your wall power. That's your your little plug-in doohickey here, right? And we're going to separate your 120 volts in the US or your 100 volts in Europe or what have you elsewhere. And we're going to separate that down into two different transformers. And in the case of the digital supply, it's very small signal, like 5 volts or whatever it's using. So it's a step down transformer. It's going to step that 120 volts down and isolate that signal from the mains. And then we're going to go into a little tiny circuit board, and we're going to regulate that, and we're going to filter it. And then we're going to provide that power to the DAC or the digital board. And the same thing happens on the analog side. This is an entirely different transformer because the analog board needs a much higher voltage. Likely, in many cases, higher than the mains. If the mains is 120 volts, so, and I don't know. I haven't seen a schematic for these. I have no idea what voltages are required, but in some cases, vacuum tubes, might need hundreds of volts, or 200 to 600 volts or more. I have no idea. So this might be a step up or a step down transformer. I don't know. Doesn't matter. But it's a transformer to provide the appropriate voltage for the analog board. And we come out of that, and once again, as what a power supply does, it's going to provide regulation. Not all power supplies provide regulation, but we're going to regulate in this case. But we need to provide filtering, and certainly we provide filtering um, here. I'm not going to get into the particulars of, we're going to talk more about that when we get into the power supply boards, because the filtering and regulation is different between the models. All right. And so we come from our regulation tube regulation board, and we provide that voltage source, or maybe multiple voltage sources, I'm not quite sure, to the analog board. And here you have it, this complete mess that I've made. This is the basic topology, kind of a generic topology of all of the audio note kit DACs. If I've erred, if I've made a mistake, if I'm not understanding something, there's no schematics on the website that I have found, and no diagrams that I've found, nothing like that, just a bunch of pictures and some Spartan text. I've done what best I can by looking at photographs and reading the text to put this together for you. So if I've made an error in some way, you're welcome to correct me. I'd appreciate that. All right. So let me show you as a picture of exactly what I just described. Here is a photograph of, I think it's a DAC 4.1. Forgive me if I'm wrong. And let's start with the analog side. So here is an RCA SPDIF input that's going to be fed down here into the digital board. Here is the DAC itself, right there, the DAC chip. All right. And then the current signal is going to come from the DAC chip. You have a left and a right channel, and it's going to be fed into the coupling current to voltage transformers right here, these little can looking things. And this is one of the things that gets upgraded as you move up in price. And then the signal proceeds over happily on its merry way to the analog tube, vacuum tube voltage board, voltage amplification board. And that's that. And once out of that, we go to the output transformers right here. They're beautiful looking. I tell you, one of the things I like about these DACs is, to me, they're whoever designed this thing, whoever the systems engineer is, whoever conceived this, put this together. I think I'm a reasonably intelligent person, reasonably. But I gotta say, whoever put this together is cover your ears now, is a fucking genius. I mean, really. I admire them. This is just fantastic. Not only in concept, but in how it's laid out, how it looks, everything. Some audio equipment are just works of art to me as well. I could just sit there and look at it, you know? Really. It might sound goofy, but maybe you guys are the same. I don't know. All right, let's look at the power supply. So your wall power comes in, I believe, somewhere right down in here somewhere. I can't quite tell. I haven't really studied it to the nth degree. Doesn't really matter. And it gets separated out into your two different transformers, your digital supply and your analog supply. So your little tiny transformer here is likely your digital transformer, and then here's your analog transformer. Your digital transformer is fed into your digital regulation and filter board, which I believe is this thing here. I believe. It appears to be. I have no schematics, no block diagrams, nothing. But it appears to be that little board there, and then that filters and regulates and provides the digital board its power. All right. On the analog side, this puppy here will step up or step down the voltage as necessary, and then will provide that power to the analog board. The analog power supply filter regulation and filter board. It'll do its regulating and filtering and then supply that power source to the analog board. That's what you're looking at. It's beautiful. If you get a chance to look at some of the high resolution photographs provided by Audio Note Kits, I mean, these things are gorgeous. All right. So, as I discussed today, we're going to limit our discussion to the digital board, and then we're going to step through in each of the parts. We're going to step through each of the boards, and we're going to talk about, what upgrades are under are being undertaken. Okay, here is the DAC board or the digital board, and as you can see, well, we have our RCA input, SPDIF, that will come into the digital board, provide your signal. There is an input transformer. I don't know when I should talk about that, but then the signal will go into a decoder chip. Then and there are other things going on. I'm talking about the important things to me. And then from the decoder to the DAC, and from the DAC to the current to voltage transformers. And we've got some resistors around here. We've got some capacitors right here, right there I'm talking about. We've got this input transformer here, and these things are all subject to quality upgrades as the price goes up. This input transformer, I don't think that all DACs have this. And I'm not exactly sure. Three of my favorite words in life are I don't know. And I really don't exactly know why. I know what a transformer does, but what effect it has or what improvements it 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 yields in a DAC, I'm not sure. So what a transformer will do though, and I'm going to draw the schematic diagram of it right here. And this is likely a one-to-one transformer, meaning it's not going to step the voltage up or down. It's just going to isolate the signal. So like if you have your SPDIF coming in, this is your RCA coming in, I'm going to draw like a positive and a negative. And negative is your ground. One side's going to go to one terminal of the transformer, and the other side's going to go to the other. And then what comes out is going to be, you really don't have a concept at this point of ground because you've lost your ground. You've lost your reference to ground. So this is because you've lost your reference to ground, because there's no direct wire between these two. It's called isolation. So we've isolated the signal from the previous system's ground. So isolation can be a very good thing in many respects, and it can also help reduce noise, and it can provide other benefits. So I suspect this is some kind of noise reduction system. I don't know, and because it appears to be a one-to-one, so I can't see this providing any sort of impedance matching. So I'm going to speculate it's for isolation purposes and noise reduction purposes, but I don't know. If anyone knows the purpose of this thing and what its benefits are, please let me know. But the fact that it's there, I'm sure it has a damn good purpose, and I'm sure it has a positive benefit or effect. All right. So that's the analog board. Now let's go down to something that I put together, and I hope you can see this. It's a little small. But this is a comparison chart of all the models. Oopsie daisies. Of all the models right here. And we're going to talk about just the DAC board today, and we're going to talk about things that seemed or appear to change as we ascend up in quality and price. All right. So let's start with the DAC chip. The DAC chip itself is an Analog Devices AD1865. Great, great chip. I have no qualms about that. I'll show you the data sheet in a second. We're not going to go into depth, but suffice it to say, it's fantastic. No issues, and it appears to be the same in all the models. And this is the heart of the. If you want to compare if you want to compare, like, as often is the case, you want to compare this device to the human body, this is the heart, not the brain. This is the heart of the DAC. And so, this is really the core of things here. So no matter which one you buy, you're getting that chip. I like that. You're not getting short shield. You're not getting short changed if you buy a lesser model, and you're going to get a lesser chip. Also, um, yes, okay, right, yes. And the same for the decoder chip. You're getting the same decoder chip. You're getting a great Cirrus Logic CS8414. Now, let me go back and tell you real quick, if you don't know. The decoder chip, basically, your SPDIF signal will come in through your RCAs. And SPDIF, and I'm going to try to put this into really plain language, is just a standard. It's a protocol. And it's a way of packaging the ones and zeros of a digital signal into an envelope, with certain synchronization and other things. So if you want to look at it this way, I look at it this way. The raw ones and zeros that represent the analog signal, they're like, I look at them like little children. Okay, bear with me, little kids. And the FPDIF signal or protocol is a school bus. I think I mentioned this before. It's a school bus. It's a carrier. It's going to take them to school. And it puts them into little seats. And you sit here, you sit there, and timed. You sit here, there, you sit here, and in sequential order, and etc. And once we arrive at school, that's at the DAC, that's school. We need to unload the school bus. Get all those little kids off. That's the bits. And so that's what this chip does. It decodes that SPDIF, and as the little kids get off the school bus, they come out one by one. Nothing but kids, no junk, nothing, just kids one by one in sequential order, in the order necessary. And that's what leaves the decoder chip and goes in to the DAC. The little kids, the little bits, the raw bits. All the junk is gone. And that's what the decoder chip does. Right on. Okay. Now, so the resolution is 2496. Okay, 24-bit, 96 kilohertz. So it's perfectly sufficient for my needs. It's modern real-world standards. More than anything I actually even listen to. So I'm doing Qobuz, if I pronounce that right, and Spotify and CDs, and I'm not really doing high-res files. I don't need it. Maybe one day I will, but so I'm, I don't want to beat that dead horse. So, but this is a modern DAC. All right, and so for all the models, you're getting a toroidal input isolation. I'm going to call it an isolation transformer. Now, as the models go up, quality improves with respect to some of the capacitors, and quality improves with respect to some of the resistors. And that's what I've shown you up here, right here. So as the models go up, and you can pause this. I'm not going to walk you through it. It's probably a waste of time. You can pause this and stare at it and look at the different models. And this is when the upgrades start to pop up. Just for one example, as soon as you go from the DAC 1.1x to the 2.1x signature, immediately you get a capacitor upgrade. And I'm not even going to tell you where that capacitor is or what it does. It's associated with the DAC itself, the DAC chip itself. And then, of course, you go up one more model, and you'll get an upgrade on all of the resistors, basically, almost all of them. And then boom, as soon as you go to the 4.1, all of it's upgraded, including the input toroidal transformer. So there's a major upgrade at 4.1. So that's like the 4.1 is like a threshold, a big jump in quality, even on the DAC board. All right, so you can sit here and stare at that and decide for yourself. And I'm gonna bear with me because I'm gonna show you pictures of this stuff too. Really cool. All right, right quick. Here is the data sheet. I'm not going to go through this, but here's you can pull this up online yourself. Here's the data sheet for the DAC, the analog devices DAC. It's a fantastic DAC. No qualms about it. No issues about it. Does everything I needed to do. Bingo. Here's a close-up block diagram of the DAC. And the only thing I really want to mention about this that's of significance to me at this point is that digital signals come in and they go into the ladder. Here's the ladder, the R2R ladder. I won't, it's beyond the scope today to discuss what an R2R ladder is. You can certainly Google that or go to YouTube. But here's the ladder itself. This is the DAC. This is it right here. Now, what comes out of this is the analog signal. But it's not a good analog signal. You know, it needs to be buffered. And you couldn't just take this. Well, I don't get it. Well, it needs to be further processed on the analog side. And normally that's in the form of buffering and maybe some filtering, but we won't get into that. Now, there's two things, there's two different paths we can take here. One path and is just take that raw signal, and it's a current signal. Current, not voltage, but current. And take that current signal out. Or if we want to be, and then we have to further convert that current signal to voltage. So that's called current to voltage conversion. That's what those transformers are, those little barrel-looking transformers. We have to do that if we're going to use that current signal. Or if you want to be lazy, if you want to be a bum, you could use the built-in op amp right here. And that op amp will convert that current to voltage for you. No way, Jose. That's not for me. I want the current signal. I want to do my own conversion. That's what Audio Note Kits does in all of their DACs. They've done it correctly. They've done it the best way possible. This is the way it should be done. If you have a cheap device, inexpensive device, they will take this output every day of the week. This built-in op amp, to me, is likely shit. Okay? All right. So here's just a quick, if you want to read this, this is the quick cover of the data sheet for the Cirrus Logic digital audio receiver. I call it a decoder. That's what I call it. This is the what unloads the school bus. Right on. All right. Now, we're finalizing things here. We're going to finalize things. The last portion of this video will be, I'm going to show you photographs of each of the different DAC models, and I'm going to try to show you pictures of the upgrades as we ascend up in quality and price. So let's start out with the DAC 1.1X. That's the baseline, the starting point, the least expensive. Of course, here's the DAC, here's the decoder, here's the input isolation transformer. Call it coupling isolation. Okay. Here are some resistors, and here are the two critical capacitors that make a difference. And these are likely to be upgraded. These electrolytics right here, likely not that critical. They probably provide filtration. Not quite sure. I don't have a schematic, but they don't appear to be upgraded along the way. Um, these right here, uh, I don't want to get into what they do. It's not necessary, but they are critical to the operation of the DAC itself and will likely affect sound, and that's why they get upgraded. And I could show you where these are, actually, how these are. Forget it. I don't want to go tangential and bore you. All right. DAC 1.1x. We're at our baseline. Let's roll. Let's go to DAC 2.1 signature. You can automatically see with your own eyes we substituted these two critical capacitors. But we can see the resistors appear to be the same. And we can see the input toroidal appears to be the same. You can study it yourself. I haven't noticed any other significant differences. Now let's move on up to the DAC 2.1 signature professional. Boom, we have a resistor substitution. Look at the resistors here. Look at the difference. So we've upgraded the onboard through-hole resistors. Oh yeah, look at this. No surface mount. These are through-hole quality components. No surface mount, except for, of course, the chips. That's not surface mount, but that's the Cirrus Logic surface mount. Other than that, and wow, look at the quality of these circuit boards too. Okay. All right. We have a resistor substitution here. So let's move on up to the next rung of the ladder. And here's the biggie. Here's the big sea change. The DAC 4.1 limited. You can see all three shebangs have changed. We have a resistor substitution again. Okay. Look at the resistors. We have a resistor, and I believe it says these are actual audio note resistors. Okay. Look at the toroidal input transformer substitution. And look at the capacitor substitution again. I don't know if we've gone backwards to the original ones or forwards to better ones. I'm not sure. Don't know. But all three. I have to assume everything's gotten better, higher in quality. Let's move up to the 4.1 limit, 4.1x professional edition. Again, we have an input toroidal transformer substitution. To me, that looks like we're back to square one, but I don't think so. I've got to assume we're getting better. I don't know. But we have that substitution, and we have a capacitor substitution. See? Different capacitors, different toroid transformer substitution. Let's move up. Now we're at the 5.1. We're at the top of the echelon here. Now we have a significant change in the input toroidal transformer. But the capacitors appear to have remained the same, and the resistors have appeared to remain the same. And let's get to the top of the pyramid here, folks, is the 5.1x professional. And all I can tell, I know other aspects of the design have been improved, but it appears to me that the DAC board remains the same. They've moved the USB input board to be hovering over the top of the digital board, but I can't see a difference anywhere else. You can see the input toroidal transformer appears to be the same as the DAC 5.1x, and everything else appears to remain the same. So there you have it. All right. That's the analog board. That's all for today, folks. The next thing I'm going to do is we're going to move up and do the same thing for, perhaps we'll talk about the coupling transformers next. And then perhaps we'll get into the analog board output transformers, and we'll go through the power supplies. Maybe if it's too simple, I'll bunch a couple of these into one video, into part two. Folks, this is Stereo Police. I hope that was super helpful. I've got a really busy schedule. I'm trying to squeeze this in between appointments, but hey, I know you guys love this stuff as much as I do, and I thought you'd find this interesting. Stereo Police. Ciao. Look forward to seeing you real soon.